Hello, my name is Maciej, and together with Przemek, we will tell you a presentation about opening Intel server firmware based on OpenBMC example. So the agenda. First, I will tell you a little bit about OpenBMC and OpenBMC history and overview. Then I will tell you what features are supported in OpenBMC and the architecture of high-level architecture of OpenBMC. Then we will go to Intel-specific features that are built on top of OpenBMC. Then I will tell you how to get involved into the community, and Przemek will give you some live demo. So it's 1998, and something new arrived in the data center world. It's called the Baseboard Management Controller, BMC. And it's a separate chip located on a server board that has multiple physical connections to multiple platform components. It also has a dedicated firmware running on it. And from the interesting part is that it had a dedicated NIC card for remote management. The first version had some basic features like IPMI support, event logging, power control, system watchdog timer, and also OEM-specific features that each vendor delivered. Okay, so it made the life of data center administrator a little bit easier because earlier every time he had to physically go to the server and do something with it, and now he can just log on to BMC Web UI and perform the same task there. But the problem was that each vendor delivered their own firmware, so in some cases still he had to go to the server room, to the server, to do something because this vendor was not supporting it earlier. Okay, so in 2015, OpenBMC arrived. The idea was to create an open source BMC firmware stack. I was not there, but I can imagine there were two reasons to create it. First of all, customers were not really happy that there's a chip that is running some black box firmware on it, and because it has great power over the platform, and it had dedicated network interface cards that not in all cases was, let's say, behind the firewall, so sometimes it was available externally. It was very tempting for the hackers to attack the BMC. So basically customers wanted to know what's going on their BMCs. And the second thing was that, imagine that there are two vendors of BMC firmware, both of them are delivering the same features, the same basic features, and some additional features. But the basic features were pretty much the same. So vendor A and vendor B were delivering RPMI support, power management, fan speed control, and so, et cetera, et cetera. So I can imagine that vendor A thought that, maybe it's a little bit stupid to do this when the competing company is also doing it. So they went to them and say, hey, we will do IPMI, you will do power management and fan control, for example. So the reasons were quite obvious. And in 2015, two companies, IBM and Facebook, decided to start the projects. Both of them were named OpenBMC. The idea was the same, but the implementation was different. So I don't know exactly what happened later, but finally the IBM initiative were able to gather more companies to join it. So between 2015 and 2018, there was a rapid growth of the community, and as a result, in 2018, OpenBMC became a Linux Foundation project, part of Linux Foundation project. And in 2020, we have like 30 companies contributing to the source code, something around 140 repositories, and a lot of email subscribers to the mailing list. Okay, if it goes to feature support, we have data center administrator can use Web UI, but they can also use Redfish interface. So Redfish was something new. It was created in 2014, and the idea was to standardize the interface between each vendor. So Redfish created a protocol, the interface that was based on HTTP and JSON and OData. And they were releasing something called schemas. So schemas they were saying that, for example, if you want to implement power management and Redfish interface to it, you have to do it in this specific and only way. So it was forcing standardization between each vendor. So then we have host management, IPMI 2.0 compliance, sensor scanning and monitoring. We can update BMC and BIOS firmware remotely. We have, for better management, we have SSH serial over LAN and remote KVM. We have user management with multiple roles, certificates, and LDAP support. And we have also virtual media that we can install, for example, new operating system remotely on the host. So this is just a top of the iceberg. So there's a lot of other features that are not listed here. And every day we are working to add new features to it. If it goes to the architecture, so we have our BMC chip and all its physical connections. Then there's a U-boot that is loading Linux kernel and drivers. And at the top, we have the application layer. So each feature is implemented as a service or multiple services that are communicating with each other over dbus. All of the services are managed by systemd. And the whole distribution is built using Yocto. So now data center admins can still use the web UI for their day-to-day task on the single server, but if they would like to do like tasks on multiple servers, they will probably do some scripting around Redfish because it's a standardized interface. Okay, so companies are still adding some additional features on top of OpenBMC. So Intel is trying to build some features that will enable and enhance usage of its hardware. So what we have, the first one is out-of-band CPU crash dump collection. So in case of critical platform error, it will automatically gather crash dump data from the CPU, decode it, and publish it over Redfish for the user. It will help to debug CPU problems, but also PCI Express devices and memory problems. Next thing is BMC autonomous SPS dump. So this will basically, also in case of critical platform error, will gather the debug data from management engines firmware and will publish it over Redfish also. And the third thing is out-of-band platform telemetry streaming. So what we plan to do is to gather all possible telemetry that's available for BMC and stream it to third-party monitoring and analytics tools. So hopefully it will give some more information about what was happening with the platform and why did it fail. So if you like the idea and you want to join the community, you have here all the links. All the code, defects, and documentation is stored on GitHub. For communication, we are using mailing list, IRC channel, and Riot channel. And from my part, this will be all. So if you're interested, if you would like your code run on big percentage of the servers soon, then this is the way to do it. And now, Przemek will show you a demo.
Okay. Okay, so let's start the demo part. I will show you how to add a Redfish schema. So Is it difficult? Yes, but only at the beginning. So at the beginning, you have to get familiarized with some new concept. Yes. So it's a quite new, quite a big amount of information that you have to gather at the beginning. So so the first time is not so easy, but the next time and subsequent ones are really easy and just a copy-paste thing. Okay, for this demo I created a simple OEM schema fortune generator. I made a service backend which serves fortunes or adages like the tool we know, Fortune. I will generate two kinds of fortunes related to computers and some questions. OEM schema will show those fortunes, and there is also an action which makes to the next fortune is shown. So okay, so the theory. First of all, we have to, of course, read the documentation. Redfish is well documented. On the VMTF page, there is a Redfish page. So take a look at also take a look at on OData standard. It's a base of the language of description of schema. All schemas are written in CSDL and JSON. To start, take a look at the structure, how the whole Redfish looks like, what are the links and where. In order to do this effectively, use mockups prepared for that reason. Redfish uses REST API, so also get some knowledge on the REST. Implementation of Redfish in OpenBMC is made in modern C++. dbus uses sdbus plus library. All is asynchronous, so we use Boost Agio for most work. Hardware for BMC is mostly based on processors with one core, so please stick to one thread model. If you want to make some threading, use coroutines, C++ coroutines or Boost coroutines. Okay, so let's do the backend. Backend is based on dbus. Interface between Redfish and backend is via dbus. Dbus is the main IPC in OpenBMC. So it's good to make the backend API coherent with Redfish schema. So create a service in the XYZ OpenBMC project namespace, adding a service name at the end, of course. It's good to expose object manager interface to get easier access to members if there are more of them. After the backend is created, of course, it's good to create .service file and allow systemd to start and manage the service by systemd. So let's move to the schema part and implementation of the schema. So if anybody wants to make its own schema, it's good to start a discussion on Redfish forum because maybe somebody works on the same feature, and as Redfish should be as generic as possible, so you can join efforts and make the feature together. After the design is completed, you have to write the description of schema. You can use documentation, other schemas, and there are a lot of them. There are also, after the XML part is completed, you have to also generate JSON version. And the files should be put in the proper location, like the below bullet. Okay, and implementation itself, we have Redfish core directory in BMC Web. BMC Web serves Redfish. We name the file using snake case, and using the name of the schema. Each type of Redfish node derives from the node class. We have collection, which lists all our items of our type. Item, which shows the properties of a given item, and the last actions. Actions are used to, for example, I don't know, start host or reset host using the Redfish API. So once we have the code, we have to register it, include our file, and place unique pointer in the node list. So, and that's more or less everything. We get a lot of helpers to simplify implementation, message error classes, to show feedback, JSON utilities to take parameters from the REST. Lots of boilerplate code. I said it's more or less copy-paste programming, just a few lines of implementation, generic implementation. And after, at the end, it's important to make compatibility check whether our schema complies with standard. Okay, so let's start a code walkthrough. Okay, so this is how the description of the schema looks like. We have our fortune property. There is an action, and that's it for now. Here we have yes, it's our backend. So the backend looks like, sorry. Okay, so at the bottom there is a SD bus initialization. Make it bigger. Okay. As the dbus initialization, we create a project object, and using ASIO run. Once the object, when we do the run, the object is created. Here we register the service in the dbus. We add some interfaces. Let's see. A little below. Okay, fortune property and generate method. It's the same as the schema description. So let's move to the implementation of Redfish schema. So first, collection. Here you have the path in the tree. Maybe do this bigger. Okay, here we set the permissions for the item. There is do get implementation. As I said, it's REST, so we have get method. We just create some data for the schema which are obligatory, and then we put some information inside. So here we take the items from the dbus. It's all in dbus dbus callbacks. Here we put the information, and that's it. Here is the item. It looks like the collection, but the information is quite different because you have the data, and here is the action. Plus, and somewhere here, we take the information from the schema and put it. Oh yes, it's here. Put it inside the result JSON. Okay, and the last one, action node. It looks almost the same, but here we have post method. Actions uses post, REST post, so implementation, we implement post here. Okay, so let's move on to the web browser. Here is the root node. Maybe this one. The root node, there is a place when I put the our OEM schema. So let's take a look at system. It's a collection of systems, only one systems available, of course. Oh, here is our fortune generator. Let's click on it. Oh. Yes, and we have fortune questions, fortune computer. Let's click that one. Okay, there is a fortune, and right now let's generate the post method. The post here is the result 204, no content. It's okay. And after we reload it, yes, there is another fortune. So, and that's all. Any questions to both parts?
Are there any plans to support the secure boot configuration and enrollment?
The question is whether there is a plan to make a secure boot, yes, secure boot implemented in OpenBMC. That's not exactly the question I can answer, because I just make some other areas of the OpenBMC, so not exactly can answer the question.
It cannot be done, can it?
No idea.
I don't think so. As far as the mailing list, I'm concerned with the mailing list right now. Yeah.
It's not possible to enroll the secure boot key using
No, I don't think there are any plans right now to do it, but I know there are plans to add some additional security features to it. I'm not sure if the secure boot will be also involved, let's say.
Okay.
Yes, on a similar note, sorry to dwell on this, but there has been this long-standing unresolved issue between BMC operation and trusted computing. So basically you have a whole engine underneath. It doesn't matter what you measure upstairs in the operating system. The BMC can basically pull the rug under your operation because you're very powerful at this level. So for years there have been mentions, please at least signal from the BMC that you're changing the configuration so we know this up there in the measurement modules of the operating system. Is there any initiative, as this has been now rewritten under an open license, has someone raised the issue, and are there any interfaces in order to get this resolved?
As far as I know, there are already plans, I'm not sure if this will answer your question, but there are plans to make BMC as a root of trust of the platform. So basically, BMC will be the let's say component that will let's say check all the firmware on the platform. Yeah. The question was the question was.
The question was, is there an integration planned or existing between BMC on the one hand and trusted computing, ROM network stuff for operating system on the other hand? That's the question.
Okay. So, sorry, it's a hard question to repeat.
May I ask the last question?
Okay, last question.
Does OpenBMC support Intel SPS edition?
So yeah, OpenBMC is communicating with. The question was is OpenBMC is supporting Intel SPS edition? So OpenBMC is communicating with Intel SPS currently. So yeah, this is the, let's say, only point of contact, the IPMI interface.
Thank you.